Good morning, guys. This is your these are your notes for distance and displacement. That's what we're doing next. This is covered in your book from 214 to 217. So if you have not downloaded the fill in the blank note sheet, go ahead and do that now so that you can take the notes easier. So go ahead and go to my documents and download the student copy note sheet and then come back. Okay? All right, so I'm going to assume you have that now. Here we go. All right, so measurements can be divided into scalars and vectors, and we've kind of talked about this already, but a scalar only has magnitude only, and what that means is you have the number and the unit. So that's how big or how small the measurement is. And here's some examples of scalar measurements. And guys, I'm going to go ahead and go through this. If you need more time to write things down, go ahead and pause it now, and then you can write it down and then move on. Okay, but I'm going to go ahead and go through it, and then you can pause and play. Okay, so some examples of scalar quantities are time, calories, and grams. Okay, so those don't have any kind of direction to them. They're just the numbers and units. Our vectors have magnitude and direction. So it's the number and unit and the direction. And these are things like displacement, velocity, acceleration, force, momentum, and impulse, which some of those you haven't heard of yet. If we don't do them in physical science, you will hear from them in physics. So you will eventually get all this. Okay, so an example of a vector would be 15 meters per second west. So that's velocity. So since the difference between speed and velocity is the direction, 15 meters per second would be the speed, but because you add direction, that makes it velocity. Okay? All right, mass and weight are two different measurements. A lot of times we use them interchangeably. Mass is a scalar measurement, and it's just the amount of matter. And weight is the force of gravity between two objects with mass. And this is another thing you're probably going to see more of in physics than in here. But force actually has a direction to it. Okay, and we're going to skip this part because it's really not important to what we're doing. Okay, so you have direct measurements and derived measurements. Direct measurements are recorded from a measuring device. Derived are calculated from a formula. Okay, so almost all measurements are derived from direct measurements. So you have mass, distance, and time. Okay, distance is how much space between 2 points, and normally it's measured in meters unless there's a reason for doing it differently. Distance is a scalar quantity, so there's no direction to it, and it can actually be negative. I'm sorry, I misread that. Since the distance between 2 points cannot be less than 0, the sign for distance cannot be negative. Okay, I'm getting ahead of myself. So scalar quantities cannot have a negative sign. They're just the total distance between 2 points. Okay, position is relative to a fixed position, also known as a frame of reference. So when you're looking at position, it's in reference to something else. So normally that's the earth or your surroundings is what is, and that's your frame of reference. Okay, so position is measured in meters and it's a vector quantity, so direction is included. All right, so in this example, we're looking at, whoops, sorry about that. We're looking at displacement. So if you start at 0, then the block right here is minus 7 meters from 0. Okay, so this is displacement. On the circle, it's 3 meters from 0, and the heart is 8 meters from 0. So pretty straightforward. You're just looking at how far an object is from where it began, and that's your displacement. Okay, so that is the change in position. So that's what the delta x is. So you can measure the displacement by taking the final position minus the initial position. Okay, so let's go through some examples, make it a little bit easier. So if you're going with the plus is moving to the oval, so plus is going from 1 to 10. So 10 is your original. 10 is your final. Sorry. XO is your original. So the change is 9, and the distance is 9. Now you would think it would be 10, but you're not starting from 0. You're starting from 1. Okay, so you're moving 9 meters. Okay, so there's a couple. Let's go ahead and go through these. If you're going from the oval to the square, your final displacement is -7. Your original displacement or your original position was 10 meters, and that's -17 is your total displacement, which is negative, so it can be negative. But if you're looking at distance, which is the measurement between 2 points, it's not going to be negative. Okay, so displacement can be negative, distance cannot be. Okay, so I'm going to go ahead and go through these, and you can write them down to review later. But just things I want to show you. I want to point out a couple of things that you can have. Let's see, this one is a plus and the square. So if you're going from the plus to the square, you're going -7. Okay. And your original position was 1. So you're actually going, your change is -8 because you're starting from 1, not 0. But your distance cannot be a negative. So the distance between the plus and the square is 8 meters. Okay, I know this is a little confusing, but bear with me, okay? You will get it. Okay, so you can pause right here if you want to get these down. Otherwise, I'm going to move on. Okay, so net displacement is the total displacement after multiple moves. Okay, it's equal to the final position minus the original starting position. Okay, and here's some more examples. If an object moves from the square to the circle, and then from circle to heart, calculate the total distance traveled and the net displacement. So the distance traveled is 30 meters. Okay, so let's look at that. You've got the -7 to 10. Okay, so that is 17-ish. Then you've got the circle to the heart. So that's going to be about 13. So that should give you 30 meters total. So that's how much, or the distance that was actually moved, not how far you are from the start. Okay, so that would be your displacement. And in the simple problems, you can just eyeball it. You've got the object moves from here, so it starts at -7 and it ends up at the heart. So you know it's 1, 2, 3, 4. Okay, so the displacement is 4 meters. Okay, now it's not negative because it's moving to the right. So that might be a little confusing, but it's moving to the right, so it's moving in a positive direction. Okay. Now, here's an example of what you're going to be doing for your homework. We're going to be working with simple triangles. So, and we're going to the Pythagorean theorem. I hope you guys have had geometry. I don't remember if you guys have had that yet. But the Pythagorean theorem is a key geometry formula. But we're going to be pretty simple with it. So I think you'll be able to catch on. So what we're doing is this guy and his family, this guy and his kids started at this tree. Okay, and they want to go to the house. Well, they have to go around because for some reason they can't go straight there. So they're going 4 meters to the other tree and then 3 meters to the house. Okay, so if Pythagorean theorem is a squared plus b squared equals c squared, we're going to make the one of these is going to be a and one of them is going to be b. It doesn't matter which one. Okay, so let's make this one a. So that's 3 squared because it's a squared. Make this one b. So that's 4 squared. And then you're calculating c squared. So 3 times 3 is 9. Plus 4 times 4 is 16. So that's going to end up with 25. Okay, but that c squared is 25. All right, so you're not done until you get c. Okay, c squared is not the end of your equation. You have to take the square root of c squared, and c is equal to 5 meters. And that's what you see here. You can also do it just measuring it with a ruler. I do want you to learn how to do the calculations, but you can measure it with a ruler as well. So the distance that he traveled is 4 meters plus 3 meters. So the distance is 7 meters. The displacement is how far they are from where they started. Okay, so they're 5 meters from where they started. Okay, and an example of this might be the streets in a town or the streets in a neighborhood. You can't go straight there, so you have to go down this street and then turn left and go down this street. So, but you know, because of your measurements, that your displacement is actually 5 meters. So you're 5 meters from your starting point. Okay? All right. So what I want you to do, and send me messages if you're a little confused. We can go through some of these. But I want you to try the applications on page 217. That's 4 problems. And like I said, send me a remind message or an email and let me know if you're having problems and we can talk about it some more. But I do want you to practice these, and these are all just triangles. So you should be able to find a squared plus b squared equals c squared. You're always solving for the hypotenuse or for the one right here. Okay? So try these out, this page 217, and let me know if you need some help. Okay, bye. Talk to you later.